Okay, there we go. So, the object of today's lesson is object creation and destruction in Unity. So, in Unity, we have worked with game objects so far, but the game objects we've been working with have been pre-baked into the scenes that we've been using. It is a very useful thing to be able to dynamically create game objects on the fly. To do that, we need to use a script. So, let's set up a simple little interactive environment. Let's create a plane, 3D object, plane, there we go. Let's give it a scale of 10 and 10. That's why 10 and 10, just to make it a little more broad. Let's make a material for it quickly to give it a color other than white. Material, color. Green is a nice color for ground, nice and friendly. Click, drag, boom. There we go. So far, so good. Now, let's create a ball which can fall inside of, like, one of these sort of normal physics things that we've done so far, right? So first we make sure this has a mesh collider. It does. Now let's create game object, create 3D object sphere. There we go. Make sure that it's above the level of the plane. There we go. Make sure it's in focus. Not much. There we go. We have a ball. If you really want to, you can make a material for that as well. Turn it a different color as well. Let's make it, what color should it be? Red, good. All right. How about red, orange? There we go. Boom. That will show up nicely. So, we want to apply a rigid body to this so that when we click play, it falls onto the plane. Very good. How are people keeping up? Do you have that so far? Good, 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 good. Okay, moving on then. So now, the object of this program is to write a script which creates a new ball, say on a fixed time scale, once every second or something like that. All right? So, let's create a new game object, a new empty game object. Call it ball spawner. There we go. Now, you can tell where it is because you get the little gizmo allowing you to control its position. Even though it doesn't contain anything, it is still a coordinate in space. So let's give it a coordinate like x is 0, z is 0, which puts it in the middle of the plane. And let's say that we put it at y is 5, which places it above the plane by 5 units. Sound good? So far, so good? Now let's attach a script. Add component, new script, ball, shall we say spawn script, just call it spawn. Open that in Visual Studio. There we go. Oh, firewall. Get out of here, firewall. So, there is a very important Unity method which creates a new instance of a game object called instantiate. But the instantiate method requires a reference to a game object to instantiate. Makes sense, right? Otherwise, how does it know what it's instantiating? So, this script will require a public reference to a game object. Public game object, let's call it, oh, get out of here, you stupid. Those aren't even good suggestions. There we go. Game object, ball. There we go. Now, we say we want to instantiate the ball once every second, which is to say once every, shall we say, 50 fixed update calls. So, let's make a public, or perhaps a private int update count. Change this to fixed update. Update count plus plus. If update count mod 50 is equal to 0, then we instantiate. Remember this from the first lab? Cool. So, the instantiate method goes like this. Instantiate, there we go. Object original. Clones the object original and returns the clone. So when you call the update, or when you call the instantiate method, the return result of that method is a reference to the newly created object, which may or may not be useful depending on how complex your system is. Normally that's useful, particularly if the cloned object has a script attached. For example, if this were to clone bullets which are being fired from a one game object, the bullets would need to know the position of the parent in order to fire, right? That's one way you can pass that in is by setting that manually in the script by taking the return result of instantiate. But for now, let's just do the simple version. Instantiate ball. There we go. So let's go back to our Unity program. There we go. So now, what we need to do, and this is like a Unity specific thing, is we need to turn that ball, which is currently in the field of play, it's in the object hierarchy for this scene, we need to turn that into an asset. We need to turn it into an asset so that it doesn't carry through a bunch of properties from the object in the scene when it gets duplicated. So that's very easy to do. You just click the sphere, drag it into the assets pane. That creates a prefab of the same name, which you can then use to instantiate more of them. Once you've done that, it's safe to delete the sphere out of your scene. Now, in our ball spawner object, you'll notice we now have the ball game object reference field. All you need to do is click and drag sphere into that pane, and things start getting interesting. I wonder at what point they're going to fall over. It's got to be soon, right? They're spheres. I don't know. Are there any Dragon Quest players in this crowd? You know the stacked slimes?
It's been a long time since I played Dragon Quest, but yeah.
Yeah. Or from Mario, the Pokies, you know, the cactus enemies from Mario. You're not going to fall over. That's so interesting. Like, come on, that's so precarious. You know what it probably is? Probably the collider is approximated such that like the exact top of it is actually perfectly flat, and the bottom is also perfectly flat. That's why they're not falling over. But anyway, object creation. Make sense? Any questions about that? So now, how about object destruction? So, I'm going to take my sphere prefab. If you double click a prefab, you go to like a edit this prefab only view, which it can be quite useful. I'm going to add a script to the ball, which allows me to destroy it by clicking on it. Once we've done that, and maybe once we do like a count of the number of balls you've destroyed, we have a video game. Really, like, it's kind of funny, but like, quite a few of your video games in the kind of Call of Duty kind of genre, like, basically boil down to like point and clicks, except the thing you're clicking is somebody's head to make it explode, you know? So, add new script, call it ball script, for lack of a better term. Load that in VS Code. There we go. And what we want to do is to give it a very simple mouse down event as a method. We actually don't even need start and update. Void on mouse down. And can anybody guess what the function name is to delete a game object?
Is it just destroy?
It's destroy. Yes. So destroy. Now, the destroy method requires a reference to the object being destroyed. So, that would obviously be this, right? Let's see how this works. Maybe some of you have been in this class long enough to know that if I'm smiling when I say that, it's probably not going to work. So, click. Uh-oh. Clicking isn't working. So here's a question. What is it doing? Pick one of these random spheres that we have just created. There's our script. So the script is attached. Now pick one of these spheres that I already clicked. Where'd my script go? The script is missing! What happened? This is a reference to the script, not the game object. Right? So when I say destroy this, I am saying destroy the script. But the game object itself, the parent object of the script, is not destroyed. So we have to reference the object one layer up. Say this dot game object. That is to say, the game object to which this script is attached. If we do that, pulling it back into Unity, spawn some of these, click, there it goes. I can, in fact, destroy the balls by clicking them. Not bad, eh? Because they're tight. So, in general, that's kind of your simplest possible example of object creation and destruction. So, question to the class. What are some occasions that you can think of where an object would be created or destroyed? Give me scenarios. Where would you see game object creation destruction? Yes?
Like a bullet coming out of a gun.
A bullet coming out of a gun creates it, yes? Would the same object be destroyed?
Probably once it hit the target.
Once it hit the target, or if there's some kind of like max range. Even if there's like no effective max range from like the perspective of the game itself, within the game scenario, shall we say, within the coding there will have to be a max range. Otherwise, you'll have the problem you have here, where you'll just have a bunch of objects be spawned forever, and the longer the game runs, the more objects there are in memory. Even though it might take you some time, you will eventually hit a limit. It's kind of a related problem to a memory leak. Because, like, do you really need all these guys? Particularly because these are physics objects, you know? You know what's interesting, though? They're kind of getting squished into each other a bit, aren't they? It's almost like a bacteria. I wonder if I played with the setting a little bit. Collision mode, continuous, interpolate, yes. So now let's do an example of modifying some of the properties of a newly created game object from within a script. Let's say, just for the sake of interest, I want the ball to spawn not in a straight column like that. I want to have a random, a cube in which there's a certain probability that the sphere spawns at any given time, right? So let's pull up our script. Let's make a new public float spawn range. That will be the size of the cube in which these things can spawn. Next, I need to collect the reference returned from this instantiate operation. So, game object ball, or no, I call it new, is equal, new is a reserved keyword, you idiot. New ball, that works. There we go. Now, new ball has the transform component, so I can say new ball dot transform dot position is equal to new vector 3, and then I provide some components. I can even randomly determine these components up here. Float x is equal to math f dot rand. Or how do you want it done? Random dot value. Yeah, there we go. Random value times the spawn range. Take the random value and subtract 0.5. So the random value function returns a floating point number between 0 and 1, which is random. If we want the spawn range, basically, if this is my point, right, and I want to generate my balls in a box around this point, I'm talking about positive and negative offsets from this point, which means I need to generate basically a number between negative 5 and 5 or something like that. Same thing in all three directions. If I don't do that, what I end up with is specifying like the top left corner. That's my registration point, and then I just go like for the same distance, right? This is a terrible marker. I banish you. So, does that make sense? So the reason there that I have to repeat that line 3 times, rather than just saying, oh, why couldn't I just take that value before that's assigned to x and assign it to y and then assign it to z? It's because random.value will roll a new value 3 times now, once for each component. Make sense? Good. So, all that being the case, let's take a look at how things work. Interesting. Oh yeah, because I specified the range is 0. Also, so the way that I did this, I forgot something important. I forgot to make it relative to the position of the parent object. So everything is spawning around 0, 0, 0, right? So all I have to do is say this dot game object dot transform dot position plus the new vector. So now, things are still spawning from 5 up, you can see spawn range is 0, but if I increase that, you can see, if I increase it a bit more, my spheres are now spawning at random points within a predefined territory. And of course, that means that they don't all just stack. Whoa. Roll right into the camera, why don't you? Now, this does not quite solve the problem that we have like a million spheres being generated, that we have endless spheres being generated, but we can still click to destroy them. What's going to happen here is eventually, because this is kind of perfectly flat, frictionless, and frictionless, some of these orbs are eventually going to do what that one did and just fall off the side. We can also encourage them to do so a bit by pulling in the size of the plane they're sitting on. Right? So, it makes sense that if a sphere drops off the map, it should be destroyed. Especially since this is like the only way to, you know, aside from clicking on them, that's the only thing that can happen to them, right? So, we can also add a little script inside of the ball, or a little part of the script inside the ball. Ball script, there we go. Private, not private, void update. If this dot transform dot position dot y is less than -10 or is less than -5, also destroy this dot aim object. In that case, let me make the plane quite a bit smaller so as to really be able to see the effect. Oh, and the spawner's range needs to be non-zero. So now you can kind of watch them. As a ball falls off the edge, they kind of just blink out into existence. And you can see that there is something keeping our list of spheres from growing forever. That make sense? Any questions about this?
Can you just go back to Visual Studio?
Oh, yeah, certainly, sorry. You want this one or the other one?
No, this one.
That thing's on, right? Yep, it's on, okay. Any other questions? Okay. Well, in my merciful beneficence, I will here end the lesson for today so that you folk have some time to de-stress yourselves before your networking test, which is immediately adjacent to this time slot. Okay?